Hello, my name is John Liu, Flow Ninja. Happy New Year's in 2021. Today I want to continue the GamePad PCF, and I want to talk about trigonometry, rotation of our objects, and also factors. So in episode 1 we built a little icon, a little monster that flies around. We're gonna improve and continue on that. So just a reminder, in episode 1, we ended up building this little Power App. It's got our gamepad component. It's an invisible component. It sits about here. There's an icon that we're moving around. That's our sprite. So we wanted to make a monster and show that it can move around the screen. Not sure why I ended up on a clock icon. We'll have to change that today. And we have a what is icon 2? Icon 2 is something I put in just as testing. We'll show that today. And we have this timer control, and most of the code is in this onTimerEnd function. And onTimerEnd function, all we really did was we say, okay, if the gamepad controller is connected, then we take the ABS, so take the absolute value of the X and the Y joystick, which is this one, and then we set that to, we use the changes to these component, these X and Y directions, and we modify that to the monster's X and Y location. And greater than 0.1 is because there's a dead zone. So let's quickly write a little note. Gamepad does not reset to true 0, and there is a dead zone we want to ignore. Okay, so the gamepad, these sticks don't truly go back to 0, 0. They go back to really finite numbers. So you want to just ignore that. Any number less than 0.1, you can consider that to be a noise, and you don't want to know about them. Okay, and one more piece of the puzzle, we have this the icon with the X and the Y set to these two variables, the monster's X and the monster's Y. Okay, so that's what we're continuing from episode 1. Now, after the episode, I've had some thoughts. I think let's tweak this demo. The clock as a monster is kind of a joke that doesn't really fly that well. So I want to change a few things. Firstly, let's just make it towards an airplane. So a plane that potentially will shoot bullets in the future. So let's go towards that. And in our icons, I'm pretty sure there's a plane. There is an airplane. And you notice the airplane points 90 degrees to the side at rest. Okay, there is a rotate value, rotation. So if we say, so in the plane, this is your 0. Okay, and then if you rotate it 90 degrees, it goes down. So if you wanted to point up, you have to do negative 90 degrees. Okay. So if that's so imagine our math, this is trigonometry. This will be 0. And in most of our mathematics textbooks from when we grew up, 90 tends to be up here. And then 180 here. And then 270. And then 0 and also 360 is here. Okay, 0 or 360 is here. Okay, and this is how our degree systems work. This assumes that you have an X and Y axis. That assumes your X and your Y goes in these two directions, right? So 0 being here and it goes up. Now, in a Power App, the y-axis goes down. X is still from 0, which is on the left, to increasing, but y actually comes down because the 0 of y is at the top left, right? So if you imagine in a Power App, the y-axis actually comes down. So that's where you keep this a little bit in mind. Of course, You don't have to memorize it because it's pretty obvious when you're building the Power App that, oh, okay, the coordinates are going the other way. So just think about this more like X is up here, and then the 0, 0 is here. So in a Power App, the direction of this degrees down here is not 270. Oops. Down here is actually, let me just do a bit of thing. So that's not 270 and that's not 90. In the Power App, down here, this is actually 90. Okay, and 180 is still the same here, and 270 up here. Okay, and that's in degrees. So if you're thinking in degrees, your 0, 360, 90, 180, 270. Okay, so if we come back here and look at this airplane again, so by default it is 0. And you see the airplane by default points to the right. That's just the icon. The icon doesn't point up, it points to the right. And as we take it to -90 or 270, you see it points up. Okay? So just kind of bear that in mind. That's the first part. The second part I want to change is because we're going to rename it. Let's just change the name as well. Okay? Okay, so we're back. So the airplane is renamed to plane, no longer called monsters, and then the main character is a airplane. Now we do have the locations, which should now be just called plane. Okay, change the X and the Y as well. These are just plane X. Plane Y. And on the timer as well. So when the timer is end, we are going to change the plane. Okay, so that's all set. Let's quickly save that. Give it a whirl. So you see the airplane is now moving. Okay. I built this little arrow. I built this little arrow as a debugging. We'll show that in a second. It tells you which direction I'm pointing. I'm pointing the control stick. And the number below is the degrees. You see this is 0, this is 90, this is 180, and this is 270 or -90. Okay, so those four, that's the degrees. Okay, let's have a look at this next piece. So the next piece, let's have a look at, which is this. Okay, and what we're doing now is this function called arctangent. Basically, this is where trigonometry come in, and I hope it's a little bit of math, not too much math, but hopefully you'll stick with me. So let's pick this. Let's draw an arrow. Let's say this is. Let's think about it. It's easier to think about it in the 0 to 90 degrees first. So let's say we draw a line that's about like this far, right? So you have basically this distance and then this distance. And both are positive because we're going down. So 0 to this y is positive. So this distance over y and this distance over x. To find out this degree, which is this bit. Okay, this angle. We need to know basically the formula basically is y over x. I need to, this is not a math channel, so I'm doing it all in pen. If this was a math channel, I would know how to type this properly. But basically, you need the tangent function, but you need the inverse tangent, because rather than trying to calculate the length, you're trying to recalculate the angle. Okay, so you want to say the inverse tangent of basically this, and the inverse tangent is, how do I do inverse tangent? -1. Let's just do that first, then type a -1 up here. Okay, so that's the function. If you run this y over x, you will get the angle. Okay, now the function to do that in Power Apps is called arctangent. Arctangent y over x. Okay, now some of you may look at this and say, well, wait, what happens when x is 0? Well, when x is 0, then the y is a straight line. So at the point of 90 degrees or 270 degrees, y over x will actually fail, right? Because you can't do a divide by 0. So there is a helper function called arctan2, and it asks you for x and y like this. Okay, and the so rather than asking you for one number, which is the ratio, and then you have to worry about 0, the arctan2 helper function is protected with the 0. So even if y is x is 0, it will just give you the correct 90 or 270 degrees. 90 or -90 in this case. Okay, so using arctangent 2 is slightly better than using arctan with the division, because otherwise you have to worry about the y-x equals 0, which is the vertical line consideration. Okay, so let's pop back here and have a quick look at this. So we're doing basically, this number is basically the arctangent 2 of the x component of my stick and the y component of my stick. Okay, and that gives us a number in radians. So we turn that into degrees, because I think our human brain is easier to understand degrees. Radians is a ratio over pi, and it's not as obvious. So so yeah, we turn that into degrees, and then you see this number. Okay, now if we just then take this number and point it at this arrow, and if I quickly look at this rotation, you see degrees of the tangent. So basically put that number directly into the arrow. And remember, the arrow also point to the right by default, so which is at 0. So if you rotate the arrow based on the degrees, the arrow will tell you exactly what direction you're looking. So we can basically take the same formula, pop it over to the airplane, go to our rotation property, which is 0, and just pump that in. And you see the airplane is also pointing down now. So if I'm playing this airplane game again, based on where I'm moving, the airplane is gonna face where I'm looking. You guys see? You see this? It's pretty cool. We could probably make the airplane go a little bit faster. It's a little bit slow. Now the x and the y is. Let's do one more. So let's clone this icon. Copy. And we're gonna rename this to the bullet. Okay, so the icon has a bullet, and we're gonna call bullet X. Bullet Y. Bullet visible. And let's define these variables up here. So set bullet X is 0, set bullet Y is 0, set bullet visible is false. Let's start with false. Okay, so let's make it true for now, because we need to be able to see it, otherwise I can't. Okay, so we have an icon bullet. Now let's change the bullet as well. It's gonna be I use the exclamation mark. Exclamation mark. Information. Okay, and let's make that a lot smaller. So maybe 16 times 16. Maybe 32. Okay. Not information. You know, I like this icon. We're gonna use this next icon. Okay, so it kind of shows the arrow. And well, let's do one more. We need the bullet direction as well. So set bullet angle. Okay. So what we want to do is here. We're gonna do this. So at the timer, when the timer is on the end, if we say if gamepad component dot pad one button 0, so that's usually the primary button, in this case A. If A is greater than 0, that means we pressed it. Let's do something. So firstly, we're going to set bullet visible to true. We're gonna set the bullet X to be the plan's X, so the plan's current location. Set bullet Y to plan Y, so we're taking the current plan's direction. We're also gonna set the bullet's angle to be the plan's current angle, which is this thing. Okay, we should probably move that into a variable at some point. Now, what else do we need? So we have so set the angle, and then let's do that at the end. So make that true at the end. Okay, and now this is a timer that's firing every game tick. So this part is more to do with handling the input controls, but then here we can use this timer to kind of keep all our objects updated. So we can basically say if bullet is visible. So if our bullet is visible, that means we fire the bullet. We're just gonna keep increasing its number. So set the bullet x to be the bullet x. Let's get our IntelliSense back first. So what's a whinging? Oops. Here we go. Okay. So plus our cosine of the numbers in radians. So we need radians of the bullet angle. And the airplane speed is 10. So let's make the bullet speed maybe twice that, or maybe just 1.5 of that. Okay, so we're basically gonna take the angle of the bullet, take the cos component. So cos, if you're not familiar, the cos is the x number. So imagine this full length is that 15, right? So that speed is 15, yeah. So the full length of it is 15. The x component of it is the cos. The cosine of this angle is x. And the sine is the y component. So x. Oops. No. I think I got it wrong. Let me just quickly double check. In my head, it's incorrect, but let me just double check. No, so I think that's sine. And we'll figure it out. You know when you are recording something and then suddenly you have a mental block. You don't remember. Okay, so that's the first part. The second part is we're going to say if the bullet x is greater than the screen's width, or bullet x is less than 0, or bullet y is greater than screen height, or bullet y is less than 0. That's a lower b, that's an upper o. Then we're gonna hide the bullet. Set bullet visible equals to false. Okay, so if the bullet shoots and hits one of the edges, we're not gonna continue anymore. Okay, so let's save that and we'll see very quickly if we did our cosine rules correct. So fly the airplane around and shoot the bullet. Oh, the angle is not correct. So I was correct initially in my head. So you don't need to, like, I don't completely remember my high school math. I just remember parts of it. So, and it's pretty quick to understand, okay, my angles are kind of off, right? So if I just switch those two around and you see, oh, you see the bullets changing angle based on my controller. That's not needed. It's traveling in the right direction, but it shouldn't be changing the angle. So I think that's because we copied the bullet. Where did the bullet go? Okay, the bullet. We copied the bullet, so it hit the edge, see, and then it went invisible. We copied the bullet's rotation based on that. So we actually have the bullet angle, which is the angle that your airplane is traveling at when you fire the bullet. So you can shoot the bullet and then go a different way. Okay. Now we only have one bullet, so whenever you click the button, it deletes or resets that bullet to where your airplane is. That's pretty fun. This is already pretty fun. And you can, do fancy things like the bee, that's a bomb, maybe. Um, you can make Bomberman with this. I mean, Bomberman can only. Oh no, the Bomberman can do many bombs. Alright, so we still got some work to do. But yeah, we can definitely make Bomberman. Anyway, I want to maybe just end here on this bullet. Check it out, follow along, subscribe to my channel, and I'll see you hopefully in the next one. Bye bye.